Welcome back to Notes for Engineers. I'm Alistair Cook, and I have the pleasure of being here at Infinio's headquarters in Boston. My first trip to the East Coast US, and it's been turning on a beautiful blue skies day. I'm joined today by Scott Davis, who is the CTO here at Infinio.
Great to see you again, Alistair.
It is indeed.
It's been a whole few weeks since we've
been
seen each
over
other.
a month, and that's a little shorter than usual.
Yeah, well, time flies when you're having fun,
Yeah, and of course we last saw each other at that great storage conference, VMworld.
Yes, that's true. It's funny that you mentioned that. I kind of noticed that too. I thought I was at a storage conference.
Because half of the floor seem to be innovative startups who understand the new storage landscape in a way that's completely different to everything you've ever had before. And what could go wrong with that?
Yeah. Well, storage is an interesting space. And as you know, I've been in and out of storage my whole career. And storage for a long time was a very static, staid kind of environment, which goes along with the persistence of your data. But there's been multiple disruptive technology trends that have changed the landscape very dynamically. And those include the impact of virtualization itself, scrambling workloads, the I/O blender effect, if you will.
And at its most fundamental level, moving from having just data sitting in your shared storage to having whole operating systems there as well. And that's quite a change in itself, let alone this explosion of the number of machines that we're storing.
Correct. And virtualization also gives you the combination of workloads, which is what causes this I/O blender effect, where you're having many more applications and operating systems worth of content running and accessing from your storage arrays. Also, storage in general, for many years, was by far and away the slowest component of your computer systems. Spinning disks were millions of times slower than compute cycles are. But there's this new innovation called flash. And flash gives you a persistent medium that, while nowhere near as fast as memory is far faster than what we've come to expect from disks. And this trend, so flash coupled with virtualization, coupled with scale-out cloud workloads, if you will, partitioning your data across numerous servers and accessing the same storage behind them, all of these things have let loose this drastic amount of innovation across the storage
and the
landscape.
need for it as well. There's a strong demand for change in storage.
Absolutely, absolutely. So when I look at the storage landscape, I kind of, it's important to categorize things and look at different types of solutions.
So you're coming from a science background. If you want to categorize everything you see, put things into buckets and understand the differences between them.
Sounds good. Well, this was going to be a technical deep dive, right?
Well, see, I've got a physics degree, and so categorization of stuff is important.
Okay, fair enough. So I have a way that I look at these next generation storage solutions. And the first thing I look at is whether we're looking at a traditional type of storage architecture, having a storage appliance, if you will, that's presenting your persistent medium back to your servers, or if you're running your storage stack, so to speak, on the same servers that are executing your applications. And that's a good way to start up dividing the landscape. Does that make sense, Alistair?
Yeah, I think so. And that I think that's one of the innovations we've seen in the market is this move from having storage siloed out somewhere else to having some parts of your storage combined with the hardware that is your virtualization platform.
Yeah. So when I look at traditional storage arrays, most of them have introduced flash in some dimension or another. And I kind of look at two broad categories here. One of them is the hybrid arrays. And hybrid arrays started out when flash first came out and was rather expensive. And a hybrid array, flash is typically not exposed as an individual as user consumable storage. It's typically used as part of the infrastructure in the array. Flash is typically used as both a read cache and a write log buffer in order to improve the performance. And a hybrid array also contains most of its user capacity is going to be on traditional spinning media. And the flash is used in order to improve the performance of both reads and writes of those media.
And we've seen one of the things I've written about is that flash is so very different from the combination of RAM and spinning disk that we had previously, that we see some vendors simply using the flash as if it was one or the other and making one or the other of those things better, yet it is very different in its characteristics than both. And so we see this bolt-on of flash and flash being used suboptimally in many of the hybrid arrays, not the ones that have been built from scratch with with the flash, but we definitely see that kind of bolt-on flash.
That's a great point, and I'll take a minute and talk a little bit about the differences with Flash, because you're absolutely right, Alistair. Flash is a new medium. It's a very different medium. It doesn't behave like memory, and it doesn't behave like disks, like traditional disks. In particular, so read and write performance is radically different on Flash. Writes are much slower and take many more operations. The reason is that both memory and disks, you can read and write the same blocks any number of times. Okay,
They're entirely random in their access, and there's no relations between the different subunits.
correct. On Flash, though, you can't write a block if it already has data in it. So the first time you go to write a block on a Flash medium, it works like you expect. But subsequent writes, you have to erase it first. But not only do you have to erase it first, the granularity of erases is not symmetric with the granularity of writes. So you actually have to Flash is divided up into what's referred to as blocks and pages correspond to what are traditional 4K disk blocks. So what you need to do is you actually need to shuffle data around in order to be able to erase an entire block in order to then write over some of the data you want to write in the middle.
To pull out all of the data you don't want to change, erase the entire page, and then push back in the original data that you didn't want to change, plus the new data. That's a serious write multiplier.
Exactly. So that's what's referred to write amplification in Flash. And it gets more cumbersome as well because Flash actually wears out. Okay. And one of the problems with a wearing out medium is if you just bolt on Flash, like you eloquently described a minute ago, the problem you run into is what's known as wear leveling, which is that if you have, for example, file system metadata that might get written numerous times, more times than the actual contents of files, well, with a medium that wears out, you don't want to wear out spots on the medium and then get errors back. You actually want the whole device to fail around the same time. So you want to be shuffling content around so that in general, you're writing the content, you're writing the blocks the same number of times across the lifetime of the device. So you got to move that aspect of the workload around as well. So Flash has a lot of complexity to it that you need to handle in software, whether this is in software for the device or software for the running in the array itself. So the other category of traditional arrays is all flash arrays, and all flash arrays is exactly what it sounds like. It's a case where the technical buzzword matches what it is. Okay, there's no spinning medium in it. We're using Flash as the storage device for directly for all of your end user data and metadata used to access it. And that can give you very high performance, but of course the array has to handle all of these idiosyncrasies of Flash.
And as Mike Laverick will tell you, all of the Flash vendors each believe they understand Flash like nobody else.
Right, exactly, and so there's a lot to it in order to create a compelling all-flash array. But both of these types of Flash or Flash deployments are actually mimicking the traditional hybrid shared storage array, and cloud-based workloads actually don't work the way our traditional shared storage arrays do. They're all about partitioning data sets across large numbers of systems. And they actually benefit from this so-called scale-out style of workload rather than traditional arrays scale up. So this lends itself to what's called both software-defined storage, which is kind of a generic buzzword, and those of you that read my blog know that I consider that that being a term that's almost gotten to the point of uselessness because it's so generalized.
Word phrase now.
But scale-out infrastructure, what this type of category is around executing your storage stack co-located with the applications on the same virtualized servers. Okay, and this can be implemented either as service-oriented virtual machines, so-called virtual appliances, or it can be baked into the hypervisor, or something in between. But it's executing on the same servers that are running your general workload. And in fact, one of the newest categories is hyper-converged infrastructure, which is about individual scale-out building blocks for running your virtualization workload. So you buy a server that has direct attached storage, network built into it, and the software involved in order to use that as a building block for your software-defined data center.
And those are really nice architectures for growing over time. You just add another unit. When you add the capacity to run more virtual machines, more compute capacity, you're adding more storage capacity and performance, and they grow quite nicely.
Exactly, and it simplifies the deployments. However, every one of these solutions has a storage stack built into them, and typically each of the vendors has built their own storage stack as part of their solutions. So that this is server-side execution software, and this delivers. This can be hybrid or all flash for the medium behind it, but it typically scales out co-located with the application in this building block model. All three of these categories that I've described so far, though, are disruptive in nature, meaning that in order to deploy them, this is a new way of operating. You have to not only buy this new infrastructure component or components, but you then have to migrate your workload into them. Okay, that's what I mean by disruptive. And there's a new way of operating on them as well.
Replacement of both your server platform and your storage platform, plus the data migration, which is no trivial task if you've got a few tens of terabytes of virtual machines to move.
Exactly. And there's most customers have a large investment in their storage platform. So there's a lot of storage out there.
It's a long-term investment as well. It tends to be a 5 to 7 year purchase decision, not a 3-year the way the server platform is.
Exactly. And there's more operational requirements, or just as many unique operational requirements around it too, where a mixed heterogeneous environment can be more complicated.
Transition time can be very painful.
Yeah, so even if you're buying a device that's, quote unquote, easier to use or delivers a better user experience from the management side of the house, you're adding more complexity unless you're replacing everything at once. So that leaves us with a final category that I deem I/O optimization. And I/O optimization is about using one of these scale-out server-side storage processing, but using it in a seamless way in conjunction with your existing traditional arrays. So deliver the performance in particular that you can get from these next-generation technologies, but do so delivering that performance on top of your traditional storage array infrastructure.
So not rip and replace of either your server infrastructure or your storage, just add something that gives you the performance that you need. Just that.
Exactly, and that's what Infinio does, where my current company is. And what Infinio does is we take a small amount of memory spread out across your virtual infrastructure from each of the nodes, and we create a distributed global scale-out content-aware cache out of that memory that seamlessly sits in front of your traditional storage arrays and delivers compelling performance on top of those existing arrays, so it can much better handle the demands of a virtualized infrastructure, but do so without having to rip and replace your storage or change any of your operational procedures.
So the simple deployment method and the easy try and all of this basically simplicity and non-disruptive deployment is a huge benefit potentially.
Exactly, and it takes a lot of sophisticated storage in order to deliver that seamless, easy-to-use experience.
Yeah, simplicity is such a hard thing to build. It requires a lot of complexity. Well, a lot of engineering hours, I can tell you that way. Okay. So we have a lot of innovation going on, and we can see that there's different ways of approaching that are very disruptive and very change intense and high risk for organizations. And it's one of the nice things on the Infinio solution is the low risk trial, easy to get into, and yet still giving you that big step function difference in storage performance when you add a large local RAM cache.
Right, and it's a very vibrant market, and that goes back to the point where VMworld looked like a storage show, and that's because there's all these categories and there's multiple vendors in each one of the categories, but it's all about moving infrastructure forward. Part of this vision of the software-defined data center, and storage is a really key component of that sea change that's going on.
So you want to predict when this wave of innovation is going to come to an end, or are you not prepared to go out on a limb on that one?
I'm not going to go out. The only thing about change is that it's constant.
The only thing that really changes the rate of change.
And, there's some next generation technologies coming here. Flash is definitely not at its end stage, and some of these technologies that we're describing are transitional. And I expect you're going to see further advances on persistent mediums, further changes in applications, all the demands of cloud computing and large-scale workloads, and it's iterative. As the infrastructure advances, all of these infrastructure technologies are about developing and running applications. And you can see as the mobile cloud era, of computing, we're in a new wave of applications, and those put new demands on infrastructure. And it's a virtuous cycle where we continue to churn and we continue to evolve and innovate.
And that's the thing that keeps us all interested in the industry.
Absolutely.
All right, I think we better pull a close on it there, otherwise we're going to talk about this all day. Thank you very much, Scott, for joining me. This has, again, been Notes for Engineers, and you can find us at notesforengineers.com.